Welcome to the CompTIA A+ 220-1101 or Core 1 exam. This lecture is about SCSI. SCSI, or what we refer to as SCSI, is the Small Computer Systems Interface. This is a standard interface that can be used to connect to storage devices, scanners, printers, and other devices on your network. This was originally designed so that you can have many devices connected to one single interface on your computer by daisy chaining multiple devices together. And many of these SCSI standards support up to 16 devices in one of those SCSI chains. This is a standard that's been around for quite some time, and honestly, personally, I'm quite surprised it's still around. It is an old technology, but it's been improving. You'll find a lot of different number of SCSI standards and different types of interfaces. One of the newest standards is iSCSI, or SCSI over IP. And certainly you'll find a lot of SCSI implementation in virtual networks as well. And if you look at some of the other connectivity that we use for storage devices such as PATA, which is parallel connectivity, and SATA, which is serial connectivity, SCSI can support both of these. Before we had SATA standards or was able to use USB to be able to connect to our peripherals, we used SCSI. SCSI was used to connect to scanners, CD-ROMs, tape drives, and backup systems, all kinds of things. And we had SCSI connectivity inside of our computers and external interfaces that you could also use. And as I mentioned earlier, you can daisy chain these devices. So a single interface on your computer might support 8 different SCSI devices on a narrow bus, or up to 16 if you're using a wide bus. One of the benefits of SCSI and the protocols that are used to communicate over these SCSI connections is that it is a very intelligent form of connectivity. You simply provide the basic connectivity, and SCSI takes care of identifying what devices are in the chain and how to access those devices over the SCSI connection. And although SCSI doesn't have the popularity that it had in the past, you may still find systems that have SCSI drives or other SCSI connectivity. And SCSI is a standard, and it's used in virtual systems as well. Here's a somewhat dated motherboard that does have SCSI connector on it. The motherboard also has different kind of connectors that are integrated with electronics such as IED interface. Today we refer to these interfaces as PATA interfaces. On the left side is the SCSI interface, and over here you'll see that there's Ultra 3 interface. It uses 68 pins on the connector. If we turn it to the side, then you can see different cables. The 68 pin connector that we see on the motherboard is just one type of many different SCSI connections. In SCSI, we're able to accomplish this by using a SCSI ID. It would be quite confusing once you have so many devices, right? So every device you connect to has a particular ID. So your computer might be SCSI ID 0, and you might be connecting your computer to a hard drive to that cable. And that would be assigned a different ID, maybe ID 1 or ID 2, and you might have another device like a CD-ROM, and every device has a different SCSI ID. If you think about connectivity to a drive array, it's a single chassis with many different drives inside of it. Because of this, SCSI has a method, not only to identify the chassis of that drive array through SCSI ID, but we can identify individual drives by logical unit, or LUN. The logical unit allows us to reference a single drive within much larger SCSI ID devices. It's also very common on this cable at the end that you can see a SCSI terminator. The terminator allows you to have multiple devices on this wire and still be able to communicate across all of the devices simultaneously. One of the more recent standards for SCSI is Serial Attached SCSI, or SAS. These devices are much simplified over the older SCSI configurations that require you to manually set a SCSI ID. With the newer SAS devices, you don't have to worry about setting jumpers for SCSI IDs. You don't have to install any terminators or make any additional settings to be able to use those serial attached SCSI devices. Here's the back of an external SCSI storage device. You see that we have a spot for power. It looks like there's a fan inside of this device or something that is cooling it. And here are different SCSI interfaces. One has SCSI out and this is a SCSI in. This is how you would be able to daisy chain these particular devices along the other SCSI devices on the same cable. Different devices will have different IDs. So if you look inside of a computer that has a SCSI controller and multiple SCSI hard drives, you'll probably see that the SCSI controller is set to a SCSI ID of 0. And then there's probably a cable from that device that goes to the first hard drive. And that drive is daisy chained to, in this case, a second hard drive, and then the end of the cable is a SCSI terminator. So here's a SCSI connection outside of the computer case. There's a single ribbon that wraps around and different interfaces that daisy chain like this. You can see there are multiple interfaces on the cable. So we continue to add storage devices as long as we have connectors to the cable. Later we will learn about PATA, or parallel communication, to SATA, or serial communication, and SCSI had a very similar evolution. One of the more recent standards of SCSI is the serial attached SCSI, where we went from parallel communication to a serial communication. This not only increased the total throughput that we have in our systems, but it greatly simplified the implementation in our computer, because this is a point-to-point connection between the motherboard and the drive. We no longer have these cables with multiple interfaces or devices with multiple SCSI interfaces, because there's no more daisy chains. We also removed the need to have a terminator, because the only thing on the serial attached SCSI connection is the controller on one side and the hard drive or storage device on the other. This gives us control and management of a well-established SCSI set of protocols, but it also provides us with speeds we need for our most modern storage devices. Here's a serial attached SCSI drive. You can see it looks very similar to a SATA drive, but the connectors on the back are slightly different and they do require a different set of connectors. An example of this is a very large connector that is a high density internal SAS connector that you would use inside of your computer. And of course there are also serial attached SCSI arrays, so that you can connect many different serial attached SCSI drives to single chases. Okay, we're at the end of Objective 3.1, SCSI. Here's a question. If a device has a SCSI ID of 0, what is it? It's more of a legacy question, but you may see SCSI daisy chains and ribbons when you're working in IT. Okay, A, hard drive disk. B, CD or DVD reader. C, a network attached storage. Or D, the controller. And the answer is, ID 0 would be a controller. That's where it starts and is the connection of the interface. Thanks for watching.